Okay, Math 30s, welcome to your Thursday recorded lesson. We're carrying on from yesterday when we started talking about rational expressions and we looked at non-permissible values. Today we're going to look at equivalent forms of rational expressions. So again, determine equivalent forms of rational expressions, and we're going to limit our numerators and limit this to numerators and denominators that are monomials and binomials. That makes it a lot easier. So compare the strategies for writing equivalent forms of rational expressions to writing equivalent forms of rational numbers. So writing rational numbers was writing it in lowest terms. Determine a rational expression that is equivalent to a given rational expression by multiplying the numerator and denominator by the same factor, and then state the non-permissible values of the equivalent rational expression. Okay, so we're going to do a little bit of investigating first. Here we've already learned to write, or should have learned to write, equivalent forms of rational numbers, which just means writing in lowest terms. If we write the rational number 10 divided by 15 in simplest form, explain the process involved, what we're going to do is take the biggest number we can divide out of them both. So we're going to divide the top by 5, divide the bottom by 5, and what we get is 2 over 3. Okay. Another thing we can do is we can multiply the top and bottom by the same thing. So we can multiply the 10 by 2 and multiply the 15 by 2, and we can write this as 20 over 30. Those are both equivalent forms of that rational expression. So determine an equivalent form of the rational number 18 divided by 42 by dividing the numerator and the denominator. So dividing, we're going to look at the biggest number that goes into both 18 and 42, and that's 6. So divide by 6, divide by 6. Sorry, I should do this down here. 18 over 42, and we're going to divide by 6, divide by 6. So that gives us 3 over 7. Okay, we're going to multiply the numerator and denominator, so let's just say multiply them both by 2. So 18 times 2 over 42 times 2, which gives us 36 over 84. Factoring and dividing out factors. Okay. So if we factor, so what that means is write 18 over 42 can be 6 times 3. And 42 is 6 times 7, and then what we're left with is 3 over 7, right? We take out the 6's. That's the same thing as what we did in A. And write a different answer for each of the parts in A. So we could have divided by 2, so 9 over 21. We could have multiplied by 3, so, 54 over 126. In terms of factoring, we could just factor out 2. So we could look at 9 times 2, and 21 times 2. Okay, so then what we get is 9 over 21. So you can do this in many, many different ways. Now, what we want to do is kind of investigate equivalent forms of irrational expressions. We want to consider both of these rational expressions, 2x over x squared plus 2x, and 2 over x plus 2. So we're going to do this by plugging in the value of each of these 4 variables and then comparing the values of each of them. So 2 times 1 over 1 squared plus 2 times 1 is 2 over 1 plus 2, which is 2 over 3. 2 over 1 plus 2 is 2 over 3. Okay, so those are the same. It might not be true for everything, though. 2 times 2 divided by 2 squared plus 2 times 2 is 4 over 4 plus 4, which is 4 over 8, or 1 over 2. 2 over 2 plus 2 is 2 over 4, or 1 over 2. So far, everything's been the same. 2 times 3 over 3 squared plus 2 times 3 is 6 over 9 plus 6, which is 6 over 15, or 2 out of 5. And 2 over 3 plus 2 is 2 out of 5. And last one, it looks like we have a pattern here. 2 times 4 divided by 4 squared plus 2 times 2 is 8 over 16 plus 4, 2 times 4 plus 8, which is 8 out of 24. So then that becomes 1 over 3. And then this one is 2 over 4 plus 2, or 2 over 6, which is 1 over 3. So what we can say about, we can say that they're the same. They're equivalent. Okay, they are the same. So what we say then is that 2x divided by x squared plus 2x and 2 divided by x plus 2 are equivalent forms of a rational expression. And we can use something to prove that they're the same thing. But what I want you to note is notice how much easier it was to work with this expression than with this expression. It was a lot easier to work with the simplified version, which we can get by factoring. Okay, so we're going to, if we write the denominator, we want to write the denominator of x squared plus 2x in factored form. Okay, so x squared plus 2x in factored form. So if we're going to factor out an x, then we're left with x plus 2. X plus 2. Then we're going to reduce the rational expression by dividing out the common factors. So we have an x in the top and an x in the bottom. So we can cancel those out. We can cancel those x's, and then this is written as 2 divided by x plus 2. Okay. So when 2x divided by x squared plus 2x is written in the equivalent form, it's said to be in lowest terms or in simplest form. We can't reduce this any further. Can't be reduced any further by dividing terms. The 2's can't be divided because they're not in the same spot, or there isn't a 2 in every term. You have, in order to factor something out, there has to be that number or letter in every single term. So to reduce fractions, we divide out factors, not terms. So factors are things that are multiplied to the number. Okay, so non-permissible values of equivalent forms. So we want to write the value as not defined if the value can't be calculated. So again, we're going to go through the same thing here. So 2 times 0 divided by 0 squared plus 2 times 0 is just not defined. 2 divided by 0 plus 2 is 2 over 2, which is 1. And then 2 times negative 1 divided by negative 1 squared plus 2 times negative 1 is negative 2 over 1 minus 2, which is negative 2 over negative 1, which is just 2. 2 over negative 1 plus 2 is just 2 over 1, which is 2. 2 times negative 2 divided by negative 2 squared plus 2 times negative 2 is negative 4 over 4 plus negative 2, and so then that is not defined, right? Because, oops, let me fix that. 4 over negative 4, so 4 minus 4, so this is not defined. And 2 over negative 2 plus 2 is 2 over 0, so it's not defined. 2 times negative 3 divided by negative 3 squared plus 2 times negative 3 is negative 6 over 9 minus 6, negative 6 over 3, which is negative 2, and 2 over negative 3 plus 2 is 2, negative 2. So 2x divided by x squared plus 2x is not defined for x equals 0 and for x equals negative 2. 2 over x minus 2 is not defined for x equals negative 2. Okay. And they result in expressions being not defined because they result in division by 0, which you can't do. And recall that the values of variables which result in the value of a rational expression not being defined are called non-permissible values, and these values are the restrictions on the variable. So note that the two, the simplest form and the non-simplest form, they have different permissible values. Okay, but when 2 divided by x plus 2 is written as an equivalent form of 2x divided by x squared plus 2x, it must have the same non-permissible values as the original one. So we would have to write this expression here. Okay, we have to figure out the non-permissible values before we simplify the expression. Okay, so that's what this is. The non-permissible values of equivalent rational expressions must be determined before dividing out factors. Okay, so we're just going to do a few more examples here. Again, remember you can stop this if you need to, if you're not caught up to that place yet. So write an equivalent form of the rational expression 8x divided by 6x minus 4 by dividing the numerator and denominator. So if we look at this, we're going to, if we divide, sorry, I'm just a little bit lost on here where I am here. So we're going to divide out, if we divide by 2, so we get 4x over 3x minus 2. Okay, if we multiply the numerator, so let's multiply by 2. So we're going to times by 2. So we get 16x over 12x minus 8. These are all equivalent. All three of those are equivalent so far. Dividing out, factoring and dividing out factors. So the biggest number we can take out of everything, we can take a 2 out of the top, which leaves us with 4x. We can take a 2 out of the bottom, which leaves us with 3x minus 2. Then those cancel, and what we're left with is 4x over 3x minus 2. So now what we want to do is figure out which of these are equivalent forms of the rational expression. We've got 6 divided by 2x minus 1. So we want to figure out which are equivalent. So the 12 on top is multiplied by 2. So if we go 6 times 2 over 2x minus 1 times 2, that gives us 12 over 4x minus 2. So that one's not equivalent. That one doesn't work. This one is times 3. So if we think about this one, we're going to times by negative 3 times by negative 3. So we get negative 18. And then we have negative 6x plus 3. So this is an equivalent one. So this one is 6x squared times 2x cubed minus x. So that would be times by x squared times by x squared. So that we would get 6x squared divided by 2x cubed. But then we should have minus x squared. So that one doesn't work. And divide by 2. So in this case, if we had divide by 2, so we get 6 divided by 2 is 3, 2x divided by 2 is x, minus 1 divided by 2 is negative 1/2, so that one doesn't work. So it was only the middle one. And consider the rational expressions 4 divided by 2 minus x and 8 divided by 4 minus x. John evaluated each expression for x equals 0. Based on his answers, he concluded that the rational expressions are equivalent. And so we want to comment on that. So all we need to do is just try a different one. He only tried 0. So let's try x equals 1. So 4 divided by 2 minus 1 equals 4 over 1, which is 4. 8 divided by 4 minus 1 is 8 over 3. And these are not equal. So they're not equivalent. So you can't just test it with one number. You have to test it with a number. A number of numbers, a whole bunch of numbers. Okay, that is, you guys, that is your lesson for today. And the work that you want to do, or your assignment that I'm going to give you, is in your textbook, page 222 to 224, numbers 1, 3 to 5, 7 to 11, and 14 to 16. And remember that the answers are in the back of the textbook, so you can be checking that all along. Okay, and have a good day. I'll talk to you again on Friday.